Hello everyone, Mr. John here from Areteem Institute with this week's Thursday Tidbit with our final AMC 1012 problem review before the exams. And in fact, let me fix this really quick here. We actually have our Tuesday Tidbit this week because our A exam date is coming up on Thursday. So remember, Thursday, November 10th, the A dates. Next week we have the B dates. So stay tuned for updates for answer keys, some solutions, things like that later this week. And the best way to keep in touch is to check out our blog, follow this page, subscribe to our channel here, things like that as well. So we have a couple more problems today. First question, is this problem about sequences? A little bit of number theory stuff from the AMC 10B in 2013. So we have two non-decreasing sequences here of non-negative integers, right? So a couple of things that I want to just note right off the bat. We have to remember our sequences are non-decreasing. That means they can have numbers that are equal to each other, next to each other, but they can never be getting smaller there. And so we have all of our kind of restrictions in this first sentence. Non-decreasing sequences, non-negative integers, different first terms. Then each sequence has the property that beginning with the third, it's the sum of the previous two terms. So this one should remind us a lot about the Fibonacci sequence, right? As soon as we see this adding the previous two terms, we want to think there about Fibonacci in this case. And that is a good way to keep in mind, and that's going to come up in some of the patterns there. And our key piece of information is the seventh term of each sequence is n. And we want to find the smallest possible value of n in this scenario there. Right, so if we start out here, right, let's just pick some variables and start writing out the terms of the first sequence. So, right, we don't know what the terms are that we start with. We have let's start here with an A and a B as our first two terms there. They're non-negative, they're non-decreasing, right? So as of now, we could have stuff like 0, 0, 0, 1, different things like that to keep in mind, right? And so then A plus B is our next term. And now I want us to start looking for patterns as we continue. B plus A plus B. Now we still have one A, but now we have two B's. A plus B plus A plus 2B. Now we have two A's and three B's. Notice this is reminding us a little bit of Fibonacci, right? We have a 1, 1, 2, 3, 5. Hey, wait, the next term here, A plus 2A, 3A, 2B plus 3B, 5B, right? So we have a 5B. Next term in Fibonacci after 5 is 8, so shouldn't be too shocked if we have a next term with an 8 in it, which we do, 5A plus 8B. And notice now, right, if we count these things up here, 1, 2, 3, 4, 5, 6, 7, this gives us our 7 terms there, right? So this actually here is going to be our value of n. So 5a plus 8b is our value of n. Now, as I mentioned, right now our non-decreasing, non-negative stuff doesn't have too much restrictions. With just one sequence, A and B could both be 0. Everything's 0, n is 0. Right? If we had 0 and 1, we would have a real Fibonacci type sequence there. Things like that as well. But, right, we're now getting into the fact that we have a second sequence and different first terms. So, right, I'm not going to write this whole thing out, but let's maybe say we start with x and y here. And then we'll have x plus y dot dot dot, right? Notice we're still going to follow this same pattern. So the seventh term here in terms of x and y is going to be 5x plus 8y there. And this is still another value of n. And here's where things like the different first terms are going to come into play. We cannot have a and x be equal, b and y be equal, right? We have to have differences there. That pair AB must be different from the pair xy. And this is where some things are going to be a little bit interesting when we're coming up with this smallest answer in this case. Now, there's some ways to prove some of these things a little bit more formally, but let's start with kind of an intuitive idea here, right? We're trying to find a small n, so our values we want to be as small as possible, right? So let's try a equals 0, right? And it should be pretty clear. I'll say a little bit more about this in a second. It should be pretty clear that if this works, this is going to give us the smallest possible value of n, as long as we pick small values along the way there as well. So, right, if a is 0, then what do we have? So this tells us 8b, right? Since a is 0, 8b is just our n value. And that's supposed to be equal to 5x plus 8y. And now we have a kind of interesting thing we want to note here. Note that n is 8b, right? So this is telling us that, right, this whole thing we have here must be divisible by 8. So 5x plus 8y needs to be divisible by 8. Well, that tells us that, right, we have here that x is, right, divisible by 8. Because the 8y is automatically divisible by 8, so the 5x has to be divisible by 8. That's only possible, or the smallest value there is going to be x equals 8. So here then we try, right, and again, we can try x equals 8 in this case. So now we're kind of done with our first terms. A is 0, x is 8. And remember that we need non-decreasing sequences. So, right, x has to be 8. Let's stick with that side a second there, right? Because that's now our largest number. B, we don't really know that much about yet, right? So it would make sense, right? A is already small. A is 0, x is 8. How about we try that our value of y is also 8 in this case? So let's kind of see what happens there then, right? So now we have that 5 times 8 plus 8 times 8 there is equal to n, right? Well, let me just kind of say here, right? So this is then 13 times 8. And so then, or 40 plus 64 if you like. This is 104 for our n value, right? This is one of the answer choices. So now we're kind of looking at some progress here a little bit. But I want to go back and think about the A's and B's a second here as well. So this is supposed to be 8b as well. So I just want to check that this b value makes sense, right? And so then we would have b equals 13 there. So this all seems to work out here. This is going to be our correct answer. And on a test, if you're in time trouble or things like that, we've always been picking the smallest numbers there, right? So maybe this isn't a full proof, but it's a pretty good way of coming up and convincing ourselves of the answer. Now, I want to do some quick highlighting of all of the terms to summarize. We have A is 0. We have B is 13 in this case. And then we have X is 8 and Y is 8 there as well. Now, if you wanted to do a little bit more of a formal proof or things like that here, just verbally, how would you go about doing that? The thing I want to notice here is that when we look at our n, right? So n is 5a plus 8b, 5x plus 8y. A and x are multiplied by 5. What I want to leave you with here is that it's not a coincidence that a and x differ by 8. Right? Our other term, 8b, 8y, those are our things multiplied by 8. It's not a coincidence that those terms differ by 5. So that's one thing you want to keep in mind there, right? We have this non-decreasing, so we try 0 and 8, and then since it's non-decreasing, the smallest possible y is 8, and then it's not a coincidence that then we go up by 5 to get to B 13 there. So try to think about the details a little bit more there if you want, but this is the rationale of trying to build that smallest number possible in this case. Okay, so let's look at our next question from a 12A in 2016, number 23. And this one is a geometric probability question. So right off the bat here, right, we have these three numbers three numbers in the interval 0, 1 are chosen independently and at random. Right, so we have these three numbers in that interval there. And this is making us think of geometric probability, right? In an interval, right, maybe we have our three numbers are A, B, and C. Right, and then we can kind of think about them. I have a little help here so I don't have to draw this picture, right? We can think about picking them in this 3D space there, right? Say we have kind of A is like our X coordinate, if you like. B is our Y coordinate, if you like. C is our Z coordinate, right? It doesn't really matter what order we do there. And we're kind of picking these numbers randomly in this cube. So we pick a point in the cube. We can do probabilities in terms of volumes, things like that along the way as well. And so that's what we can kind of think about there too. Now, you could draw this out for all these A, B's, and C's, right? We're going to think about some stuff with the triangle inequality. Right, so as soon as we see this stuff, hey, we have, right, chosen numbers are side lengths of a triangle with positive area. We want to be thinking here clearly about the triangle inequality. So we have the triangle inequality there. Now, I'm on purpose not writing that out yet. So why is that? Well, for a lot of these geometry and probability questions, a lot of counting questions in general, you want to try to think about assumptions you can make here. So we're picking three numbers. Is it more likely that C is bigger or A is bigger or things like that? No. So the assumption we can make is, right, we can assume that A is less than B is less than C. For geometric probability, remember that the actual specific equalities don't matter, because that is probability 0 of happening. So we can say, okay, let's just assume A is less than B is less than C. Now, first of all, that simplifies our picture in 3D a little bit. We need to be careful there, right? So the way we could think about that, right? Maybe you can plot points, right? If they're all 0 or something, right? This would be something that's kind of a boundary point, right? So if A is 0, B is 0, C is 0, right? Or maybe A is 0, B is 1, C is 1, right? Or C is 0 or C is 1, right? Or we could have kind of all three of them or are 1 or things like that there, right? And so of course something like 0, 0, 1 also works. And so I do want to point out, even though we're not going to do too much with this, right? We kind of actually have here, whoops, and let me just clarify, we do not have this b equals 1 unless c equals 1. So we actually have this pyramid here. We have this triangular prism, or triangular pyramid, if you like. That is the region we're looking for here. So this is kind of this triangular pyramid in that case. Now, right, that can be a little bit difficult to visualize. So let me actually do a little preview of something that's going to come into play in a second and is our big trick for the problem as well. Right, so what is a good way to help visualize 3D shapes or visualize 3D things there, right? It can sometimes help to look at kind of specific values of C, right? So let's look at a picture here and say, what if we have, right, for a fixed C value? So what does our picture kind of look like in that scenario there, right? So for a fixed C value, what's going on in our inequality even, right? So if we have a fixed C value there, right, notice that we have A is less than B is less than C. So in fact, we can turn our entire focus onto between 0 and C here. So we could graph our value of A on the bottom, our value of B on the left-hand side here. And then if we're graphing A less than B less than C, right, what is that going to look like? Well, we have the equality case there, and then the region where A is less than B is going to be this upper triangle in this scenario. So we didn't do anything with the probability yet, but I just want to point out that this is a way that can sometimes help you come up with, okay, how, if you're having trouble visualizing that pyramid, right? Okay, as C grows, we have this triangle that's growing, and that's where at the top we have this full half of this square face on the top, and that's shrinking in this triangular pyramid down to the origin there. Now, that, right, can help in general. You can then say, oh, it's a triangular prism, the base is a half, the height is 1, its volume is 1/6. You could calculate probability in terms of volumes. But something very nice happens when we look at the triangle inequality here. Now, in general, if we had 3 random numbers, we would have 3 inequalities here. But if we know the longest side is C, our triangle inequality simplifies to C is greater than A plus B. So that is our inequality there. Now, if we want to look at this in terms of kind of some, whoops, A plus B needs to be greater than C. So I have this order backwards here, right? The 2 shorter sides need to get longer than the last side there. We could do complementary counting the other direction, but let's look at it directly here. Now, in terms of our graph, this is telling us that B is greater than C minus A. And here's where something very, very special happens. So let's graph that on our plane, our fixed C graph here. So we have a line, right, with a slope -1 in the XY plane or BY plane if you like. And we need B to be larger than that here. Remember, we really only care about this yellow shaded region. So let me highlight this kind of triangle up there in above this C minus A line and above the kind of B equals A line in this case. Now, here is where the magic happens. You could try to start thinking about, well, what picture does this give us in that XY plane again, right? We kind of have another type of prism or things like that here. But let me kind of notice something, right? Notice that for all C, right, this probability, right, the probability we have shaded, we have half of the region shaded there. So no matter what that longest side is, the probability that the other two sides work is a half. And so in fact, that's enough to determine our final answer, right? So for example, if you had some complicated things where this happens or this happens or this happens, but regardless, at the end, if you were flipping a coin and it was heads or tails with probability 1/2, you don't really care about the details of the different cases. That's kind of what's going on here. No matter what C is, actually, for the other two sides, there's always a 1/2 chance of it working. So that gives us a 1/2 chance in total in this case. So think about that. You can try to graph that region of A plus B is greater than C in 3D space, or use an online graphing to do that. That can help visualize it. But actually solving it, you want to take advantage of these two symmetries. A is less than B is less than C, so we can deal with C being the largest right off the bat. And then noting that actually for a fixed C, it's always the same. And then things work out nicely from there. So that will do it for this video here, right? Stay tuned for updates on the AMCs this Thursday, right? Good luck to everybody taking the exams and things like that this week and next week. And let us know if you have any comments or ideas for future videos. And most of all, thank you all for watching, and I'll see you next time. Goodbye.